This is an extension to question number 3 on test 3. As we know from the test, the rectangular equation for this hyperbola is y squared plus 4 is equal to x squared. In this video, I'm going to turn the rectangular form of the hyperbola into its polar form. So we already know that x is just equal to r cosine theta and y is equal to r sine theta. So I substituted in r sine theta for y and r cosine theta for x. So what I have here is r squared sine squared theta plus 4 is equal to r squared cosine squared theta. And then I wanted to get r by itself. So I divided each side by cosine squared theta minus sine squared theta. And so for the polar form, I have r squared is equal to 4 divided by cosine squared theta minus sine squared theta. This is a polar equation for this hyperbola. However, if I want to confirm this equation in my calculator, I will have to take the square root of each side so that r is, instead of r squared, it's just r. So I have 2 divided by the square root of cosine squared theta minus sine squared theta. And this is the polar form for this hyperbola. And what I'm gonna do right now is I'm gonna generalize the polar equation for a hyperbola. So the polar equation for a hyperbola is basically r squared is equal to a squared b squared divided by b squared cosine squared theta plus or minus a squared sine squared theta. And this equation only works if the hyperbola is centered at the origin. So over here I wrote the standard rectangular form of the hyperbola because I want you guys to see where I get my a's and b's from. So it's basically just from the standard rectangular form of the hyperbola. And I put plus or minus because that's going to change which way the hyperbola opens, and this is what I'm going to explain right now. And just if you want to type it into the calculator, you have to take the square root of each side because you have to get it into r instead of r squared. So if you want the hyperbola to open sideways, in rectangular form, it would mean that x is positive and y is negative. And in polar form, it would mean that in the denominator, you would have b cosine theta squared minus a sine theta squared. And or you can square each side to get rid of the radical sign. And if you want the hyperbola to open up or down, so in rectangular form, it would mean that x is negative and y is positive. In polar form, it would mean that in the denominator you will have a sine theta squared minus b cosine theta squared. So basically, you can see the difference here. In this case, you have minus a sine theta squared, and in this case, you have minus b cosine theta squared. And it makes sense because going back to the relationship that we have over here, y is, it kind of corresponds to sine theta and x corresponds to cosine theta. And in this case, we have minus sine theta, so it's kind of like saying it's minus y. And in its rectangular form, if we know that y is negative, then the parabola opens sideways. And similarly, in this case, we have minus cosine squared theta. So cosine theta is kind of like x. So it's kind of like saying it's minus x. So x is negative. So we know that the hyperbola should open up or down. So that's basically it. And also, I found something online that's kind of interesting, and I want to share it with you guys. So this is something that we did not talk about in class, and I found out that basically you will also have directress for hyperbola. So for every hyperbola there are two directrices, and each is perpendicular to the line joining the two foci. So in this case, the hyperbola opens sideways, and I label the vertex and the foci. And so as you can see, the directress is perpendicular to the line joining the two foci, and it's kind of like how we would define a directress in a parabola, because the distance between, so if you pick any point on this curve, the distance between the point on this curve and the focus must equal to the distance between this point to the directress. And one thing to notice is that if the hyperbola opens sideways, then the directress takes the form of x is equal to some constant k, whereas if the hyperbola opens up or down, the directress is going to take the form of y is equal to some constant k. So this is something new that I learned, and I hope you guys also learned something new from this video.